Yo, what's up, what's up, what's up? Welcome back. Today we're working on my terminal emulator. His name is Termy. You know, he's not very good. He doesn't really do much right now. If we run him, you know, we've got like a little basic terminal. I can like ls in here. Last stream we implemented clear, so that's pretty exciting. But that's pretty much it. All we've done is we've like spawned a shell using Linux's like pty sudo terminal device handle, and we just like dump bytes into this file descriptor and we read them back, and we have like a terminal that's kind of working. We also are like rendering this cursor here, but other than that we haven't done a lot. So like even if I try to like backspace, just like nothing fucking happens, which is great. So we're pretty rudimentary right now. And today what I wanted to look at was adding colors. So previously when I typed git status, I saw a bunch of like, you know, usually it's supposed to be like red if there's nothing there. Last time I tried this, I thought that I saw a bunch of corruption in here, but it doesn't look like that's happening anymore, which is interesting. So Git somehow knows that we don't support colors, so probably we have to fix that. And then we also have to add support for rendering the colors at all. So first thing we're probably gonna have to do is flag color support. And then we'll have to look at adding, like, actually doing it. Well, I think that's the plan for today. That's the plan. Okay. So let's just jump right in. So I guess we have to figure out how the fuck Git is determining that we don't support it. Yeah, so maybe let's, if I run ash in this terminal, yeah, that's working fine. So I guess we should probably maybe look at the Git source code. And maybe try to figure out what the fuck is going on there. Which I thought I had cloned, but I guess I don't. So we can just pull that in real quick. Git on GitHub. Surely the Git source code is here. Surely. And we can maybe clone this guy. Copy, please. Git clone depth1. So I don't want to waste time downloading everything. I just want the most recent, the latest and greatest. Let's just take a look. So I think if I remember correctly, there's like a status executable somewhere. Oh, oops, I should go into Git. So when I type git status, what the fuck happens? Git status, git status. None of this looks like what I want. Maybe we browse. Maybe we browse. Oh, here we go. If I remember correctly, they have like files that represent each of the commands. But I don't see a status one actually. So, man, git. It doesn't work in this terminal. Fuck. Git help. And maybe we can see git status help. Git status help. That terminal's like got some busybox shit in there that's breaking it. Are any of these things, does it talk about like color in here at all? Command honors color.status or status color. It means the thing, the latter is kept for compatibility, blah, blah, blah. Colorizes output. Sure. Okay. I think I've seen like no color before on the Git command line. Yeah, dash dash no color. So maybe we can get git diff. Oh. Maybe in this mode. Git diff. So that's showing colors. And is it doing this one? No. Okay. So that's pretty interesting already. Because this shell has like busybox in it because we didn't want like a complex bash shell. So I think that like there's something fucked up with that environment in general. But it's interesting that these guys are behaving differently. And maybe we can look at the Git source code. Oh, sorry. I wanted to try git diff no color. Okay. So we can probably grep the source code in Git or no color. and try to figure out who the fuck is using these. No color with a quote is not matching anything. A bunch of like PO shit. Can I like set how do I like man grep? Is there a way to like filter it by patterns? Exclude. Yeah, maybe if I type in like -e dot .po and then search for color. No, that's not fucking working. Ugh, maybe we get out of him and we do it manually. Grep -ri -e dot .po and then we search for, what are we searching for? No color. No such file or directory in this directory. Okay, so that's not how I thought this worked. Man, grep. Use patterns as patterns. Oh, I thought it was didn't I see an exclude somewhere? Was I just not reading? -- exclude. Okay. Nope. We're still seeing things that end in .po. Am I high? Man get exclude. Oh, not man grep, sorry. Exclude. Skip any command line file with a name suffix that matches the pattern glob using wildcard matching. Ah. So I'm supposed to do star.po. Oh, there we go. And maybe -- exclude. Can I do like -- include star.c? No. I don't understand why I'm not seeing this like anywhere relevant. That's pretty crazy. Maybe we just search for the word color. Ooh. If color stir buff add with color, he looks for this color guy who comes in. That's not helpful. Not helpful. Append line with color. Line color equals colors. Ugh. Ugh. I wish it was easier to find what I'm looking for. I'm sure I've found this before. I'm just like missing an important grep. Maybe we can look up like terminal check if color is supported. That'll give us a clue. How to check if bash can print colors. Check if stood out as a terminal. T-put colors. Man3 term info by using, oh, is a TTY and the, okay, so is a TTY matches this, which we're probably correctly saying we are, and then someone is using term info, maybe. Man3 term info. Really? Term info. Term info command not found. Great. Great. T-put colors. What's that? 256. Okay. T-put colors. 256. So that's not T-put colors. Oh, fuck. T-put colors. So all of these guys are flagging 256. So that's not why Git is not printing any colors. Why? So Git check colors disabled. Let's so okay, let's look at like the Git log stuff maybe. Is there a log? Let's see if there is anything interesting here. So where are my like entry points in Git here? Like, is there like a git.c? Ooh. Oh, wait, hold on. Git No, those don't look like it. Where's like main? Git.c. List commands. So where do these built-ins come from? List built-ins come from commands. Okay. And this has all of this stuff. Okay, we're getting somewhere now. We're getting somewhere. So when I run git status, what happens? Status runs command status. Ah, which is a function. Haha. Haha. Okay. And he must parse options where we're not seeing no color. But maybe there are like default options. Git status, no color. Oh, he doesn't like that. Git log, no color. Okay. Maybe we'll try looking at git log. First of all, yeah, okay, so he's definitely dodging something. So let's go back where we were in git.c, and we saw command log. Nice. We can look for command log, which probably returns an int to match the function signature. Nice. Now, he runs command log init defaults. Okay. And who parses these like arguments? These guys. Here we go. Okay. So he parses options with built-in log options, blah, blah, blah. So why does this guy, I don't see like no color in here. I didn't see no color fucking anywhere. I swear I'm missing something really obvious. Maybe if they prefix stuff with no, and maybe I should be looking for color. And diff.c. Okay, here we go. Opt color flag. Ooh. What's that mean? Opt color flag. Introduce an option that takes in an optional argument that can have one of three values. Always, never, or auto. If the argument is not given, it defaults always. The dash no form works like dash long never. It cannot take an argument. Okay. If auto set int var to 1 if stood out is a TTY pager, 0 otherwise. Okay. That's something for us to start looking at. So opt color arg on diff. And he sets use color. Got it. And this says want color, use color. So what does want color come from? Want color. Want color. Who defines this guy? Pretty? Pretty sounds right. If want color, nope. Where is he defined? Am I high? One of these guys has got to define want color FD. Okay. Int want color FD. Okay, so if var check auto color, this sounds, here we go, is terminal dumb. So he checks if it's a TTY, and if it's a TTY, or this shit, then he also checks if the terminal is dumb. Okay. Is terminal dumb. So this must be the check we're failing. So here we say, if the terminal is not set or the terminal is set to dumb. Ah, okay. Wait, hold on. Echo term. Echo term. Term is set. What about in here? Okay, so both of these guys are trying to display color, which makes this even more confusing. More confusing indeed. I wonder if we can, like, log this in some way. Maybe we should compile git ourselves, add some logs here, and that'll give us some clues if that's working. Or we can just say, git status color always. No. Git log, fuck. Pager equals cat git log color. Fuck. I wish I could backspace. Fuck. Okay, let's test the command here. Git log color always. Color equals always. Okay. So maybe something here is just fucked up. Pager equals cat. Ah. So maybe maybe my terminal, maybe like whatever busybox, maybe I installed busybox and it installed less and the busybox less is fucking stupid. I'll bet you that's what's happening. That seems pretty likely. So if I go pager is equal to cat to dodge some of that stuff, first of all, if I do git log, nice. Okay, so maybe their less just doesn't propagate ANSI escape codes. So let's try this again. We say pager equals fuck. Pager equals fuck. It's off screen now. If only my program worked. Pager equals cat git log. Okay, so it looks like it still knows. Color equals always. Interesting. For sure, interesting. So I don't see, maybe we're not logging. Maybe we're like noticing the ASCII commands and like not handling them. Or it's not outputting them. It would be interesting to know. Okay, let's go back one commit here and run the same test because it could be that like the handling that we added to our pager to our terminal for clear might have like accidentally swallowed some of this stuff. Git log color always. Ah, okay. So no, that's okay. So we are seeing some like bullshit here. And if I just do git log, I'm seeing lots of bullshit. Okay, git log, oopsies, I want a pager equals cat git log. Okay, sure. So we've got a bunch of like bullshit here that and maybe we were just swallowing it on the latest command. Maybe. Git checkout origin master. Maybe git checkout master. There we go. Oh, god damn it. Cargo run. And what was the command we were running? Pager equals cat git log. Aha! Okay. So I was thrown off because we're probably now handling escape codes well enough that we don't print them, but not well enough that we're actually doing anything of value. And Git is probably still trying to print them. So let's look at that. In our ANSI stuff, let's see what we're doing here. So first of all, what are the color codes? You escape followed by some shit followed by an M. Is that what I'm seeing here? Escape, open brace, 38 thing. Okay. So can we just like print that manually? Bash echo escape code. I just want to try printing something manually. Bash echo with color. So they type printf echo-e. Okay, this looks right. Let's do this. Let's do this. Just a test. So if we do echo-e, and then we pass in this hunk of trash, and then write test, we do get red, which is good. Okay, so this is the escape code. Then they're doing 0:31M. Okay. So that should be hitting our parser for that stuff. And we should be hitting this CSI parser, where CSI stands for like control sequence or something. I don't remember. But this is the part that runs for like escape this, which is the first two things here. Then we should run this guy, and he should parse out like things of the format n:(m). And then maybe he's like never finishing, but if he's never finishing, he wouldn't print anything. So at some point he must be finishing, and he must be seeing, I wonder, let's get log this again. Fuck. What was it? It was pager equals cat get log. And are we missing anything? It just says commit right off the bat. Get log. No, it is pager equals cat get log. No, okay, so we're not missing anything as far as I can tell. So this guy's supposed to print, I have an unhandled CSI code. If he sees a CSA parser, maybe we should print line on invalid as well. That seems interesting. Print invalid CSI sequence. And maybe this will print. Because we're not hitting the other cases, and we should be in this branch code. Probably, maybe. I don't know. Let's see. Pager equals cat get log. Ah! Okay, there's a clue. Okay. So it looks like... Oh, I bet you I know what's happening. I think what we're supposed to be doing is we're supposed to be saying, once we see this stuff, we're trying to put... We see the escape code, we succeed. We see this, we succeed. We see a number passed in for n and then for m, and then we're expecting to see one of our like supported, or one of like our terminators that we've written down here. We just like copy pasted this from somewhere, and this isn't like the m that is the terminator in the case for color, and so we're probably trying to parse the m as a number, right? We're considering like we'll call this like num1 and num2, and then we see an m, and this is supposed to be like, okay, we're done, but instead he's like trying to like put m into part of num2 and being like, what the fuck, that's not valid. So we just have to fix that. Which is concerning here because I don't think that this like CSI terminator list is like complete. But I bet you if I did like this, we would start seeing a log that says unhandled terminator. So let's take a look at that. Pager equals cat get log. There we go. Unhandled CSI code m. Perfect. Okay. So actually was already done. We'll say here. Kinda. And now we can start looking at like actually parsing this guy. So we know 0:31 should be red, and we can start looking at like why the fuck is that. So 31 red. Okay, what is like the 0 in this? Does somebody in this Wikipedia page talk about what the 2 parameters are here? Colors. The original specification only had 8 colors and just gave them names. SGR parameters 30 to 37 selected the foreground color, while 40 to 47 selected the background. Quite a few terminals implemented bold SGR code 1 as a brighter color rather than a different font. Okay. To get black letters on a white background, use 3047. Okay, that makes sense. To get red, use escape 31M. To get bright red, use escape 131M. So, okay, so they support... Oh, so this is all part of this SGR shit. Okay, so the control sequence CSI-NM named select graphic rendition sets display attributes. Several attributes can be set in the same sequence separated by semicolons. Each display attribute... Ah, okay. Interesting. So before, we were kind of assuming that we could only ever get 2 parameters, and we were naming them N and M because we just looked at this list here and we saw, oh, there's only ever 2. But it looks like the spec is actually kind of different. They're kind of saying you can have as many parameters as you want. I wonder if somewhere we can see like C1 control codes. This is like if like what is like actually supposed to happen here? Because clearly we're parsing it wrong. Is there anything interesting in here? If you use the same blah blah blah. None of this seems like what I want. I want to know like what is the like format that we're supposed to be following. C1 control code spec. I don't know. This is just where we just were. Maybe we missed something interesting. 32 plus a delete. How does it like end? Terminator. Not useful, not useful. So we allow these guys. Or maybe this comes from like some reference. Extension of the 7-bit coded character set. Maybe this is interesting. Oh my god, it's photos of a book. Oh, this doesn't seem easy to parse at all. Maybe this GitHub gist will tell me. Maybe not. This is kind of more of like a user. This doesn't look like what I want either. I think I found something at some point that looked kind of nice. It's like ANSI spec online or something. I don't know, man. ANSI spec online terminal. I swear I was reading something earlier on my phone that looked reasonable. C1 control codes. Spec. No, I don't think I'm gonna find it. I swear I read like some sort of... Oh, maybe it was this. Nope. Definitely not that. Alright. I give up. Okay, let's just handle this now known case where we have arbitrary numbers of parameters, and we'll kind of just base it off what we've seen. And I'll try to like do some Googling off stream to try to like correct this more properly later. But for now, let's just say that we have parameters, and it's going to be like a vector of numbers. Oh wait, I just remembered one more thing that I could Google maybe. C1 control code intermediate. Maybe this is what I... Ooh. Okay, well, this wasn't what I saw, but this looks maybe more like what I want. Do they talk about, like, how to find the end? C1 in the columns 8, 9, blah, blah, blah. Okay. You can also code C1 as 7-bit escape sequences, blah, blah, blah. I swear I saw somewhere that there was like a list of like it's just supposed to be like a range of things that act as the terminator. C1 control code terminator. God damn it. God damn it. All right. We're back to giving up. Okay. So for now, we'll just assume that the format is something of the form escape, open brace, A, B, C, D, E, where all of these guys are numbers. We'll assume for now, followed by terminator. And we'll still just hard code the list of terminators, and that's fine. That's fine. Okay, so now we have params, which is going to be start empty. Okay, and now what we can do is our parser state becomes simpler. Before we were saying like, oh, we're either parsing the first or second param. Why is my indexer not working? LSP info. He's running, so why can't I jump to definition on this guy? That's weird. But now we'll, instead of saying we're parsing one or the other, we'll just call this like a generic params state. And we'll just behave the same for all these. We'll say, so params. And if we see a semicolon, then we will say self dot params push, not self, buff params. Nope, self params? Yeah, self params push, finalize CSI buff. Yup. And we've taken the buff. Okay. And maybe for now, these guys will be options of use sizes, or maybe we'll only push parameters. Yeah, we'll do it this way. Option use size. That makes sense to me. So either there was something given or there was nothing given, and what the nothing is will be different depending on which command we're running. So previously we had like a row column where we had n, m, and you could like omit n. So you could do something like escape, open brace, 1, 1, and then I can't remember what the thing was. Like it was H. I think this means like move the cursor to 1, 1. But this could also be done by just omitting the first and second parameters, because 1 were default. And then if you did something like escape, omit the first parameter, and then pass in like 20, this would move the cursor to 120. And so we have to support flagging that we had a parameter that we skipped. That's an important thing that we have to do here. So this guy being option use size makes sense to me now. So if we see a semicolon, we push in our optional, we skip this, and we do the same if we see the terminator, but we switch our state. And we're chilling. And I guess we start in the param state. And if we find the terminator, then we say, oh, we're finished. We're chilling. Okay. So that should now mean that we're like mostly good, except these guys were now expecting it to have like a certain number of parameters. And so now we can say let x is equal to parser params get 0, where he's looking for the first thing, and he might be empty. He might not have provided anything at all. But if he did, we're going to map the value to x unwrap or how do we want to do this? So we have like vec option use size. So if we say let x is equal to parser params get 0, this is a option use size. So I think we can do like let x equal to x flatten to turn this into an option use size. and then unwrap or 1. Does that compile? This is like something like this. I think that's right. Is not an iterator. Can I do like what are like what are my parameters on options in Rust? Let's see. Let's just take a look. You know, let's take a quick little peek skis. I thought there was some sort of like flatten on here. Flatten, yeah. Converts option T to option T. Yeah, so what the fuck is the problem? I was right. So is it that this guy is wrong? Oh, okay, so this works. So what is the type of this without this? Why is my fucking language server not working? Sorry, I'm not mad. I'm not mad. I'm not mad. But I don't understand why this isn't running. Because usually I can like hover on this. LSP info. Like, is there just something fucking wrong? I'm so lost. I don't understand. But we'll just live with it. I don't know. Ugh. Okay, like, it'll tell me if I do this. Cargo run. Option. Oh, it's an option ref usize. Okay. So this is X option. I see. So this is option and option usize, which is a pain in the ass. So I do get what they were saying. They were saying just write copied here, and everything is fine. Everything's fine. Okay. Flatten, unwrap, or 1. And we'll maybe even say let extract param is equal to a little, we'll do a quick little lambda or closure here. Parser params get I copied, flattened, unwrap, or 1. And then we can say extract param 0 and extract param run. Nice, we did it. We did it. Here we are assuming in this case that there is no second param. So we can say like assert parser params len is less than 2. It's kind of what we were assuming here. This is a bad assertion, by the way. Should not crash on invalid input. Like, this is obviously just wrong. We shouldn't fucking do that. But that's okay. And we can do the same thing here. Parser params get. Looks like this extract param thing maybe is generic enough that it's worth pulling out. So we can say what? Function extract. Maybe we'll put this as a method on this guy. Yeah, that makes sense. Function extract param. He takes self by reference, and we give him an index, which is a usize. And this will give me back an option usize. Yes. Okay. And this will be like self params get I. And we can skip some of this bullshit flatten stuff. We can actually just say let sum param is equal to this. Else return none. Yeah. And then this is, do we just do it like this? No. Like this, maybe? Option reference usize? No, we just do option usize. No, okay, so we're good. We just do self params get I copied flattened. There. Okay. So now we have parser extract param 0 unwrap or 1. There we go. And then we can do the same thing down here. We can say parser extract param 0 unwrapper 0. Perfect. Perfect. Maybe we just do this. Perfect. Okay. Do we compile? We do. Hooray! And clear still works? We're chilling. We're chilling. Wow, okay. So we now have support for an arbitrary number of parameters. Let's run our cargo test just to double check that we didn't break any of our... Ooh, we did. We broke some stuff. So what did we fucking break? First of all, git stash, cargo test. Make sure that this wasn't broken before. Okay. So what did we break? What did we break? Because we expect nothing to have changed here. So here we were testing that if we passed in a bunch of semicolons, that this is invalid. Oh, and this is just no longer invalid. This is just legal now. So that's fine. This is still invalid. This is still invalid. Okay. Cargo test. Okay, so that's that one done. And 1E7. This doesn't like... Set cursor pause is not going to the right spot anymore. Oh, that's interesting. So what did we get instead? Can we like print line parsed print line a debug of parsed 0. What did we fucking break? 32. Ah, because we forgot to change this to a 1. And that's why it's nice to have unit tests for stuff that should be fucking brain dead simple. Because when you refactor like this, it's easy to introduce a mistake. Here we should clear the buffer. Buff equals... We just debuff.clear like this. Because we were accumulating a 3215, and this should have been said 3215, and it was... It should have said x32, y15, and the 32 was getting left in there from the previous parameter. So, there we go. Easy, easy, easy. So now, we should be able to... What do we want to do here? We now should be able to look at colors, and we should end up in this state now where we say, hey, we finished parsing our CSI thing, and it ended with an M, and we're going to have like some list of params. So we can maybe iterate over them and like determine what to do based off of that. So we can say like for param in parser params, these are all going to be some of those like SGI codes, I think, that we saw somewhere on Wikipedia. Wikipedia ANSI escape codes. Sure. Okay. So here he was saying SGR, select graphic rendition. And so this is going to be the control sequence CSI and M. Several attributes can be set in the same sequence, separated by semicolons. Each display attribute remains in effect until a following occurrence of SGR resets it. So we could, for now, let's skip most of these. We'll handle reset and colors for now, right? The goal for today was to get colors working. So we're going to match param. And I guess for each parameter, we are going to push some sort of state, like a thing to terminal output, right? So we're saying like, hey, here are like the things that the terminal output that we've gotten might be requesting from us. So right now we support like clearing, we might get like regular text, we might get like a set cursor position request, and now I guess we're gonna have like pub enum sgr. Maybe we want to use this select graphic rendition. Hello, welcome. Welcome. And then here we'll say that the terminal might be requesting some sort of graphic rendition. Maybe we'll call this SGR. And this guy needs equal and partial equal for some of the other stuff to continue existing. And he's going to have like a reset for 0. And then let's handle these colors here. Can we like, if I copy this and paste it into this, is there a way to extract? Yes. Yes, there is. Okay, so for each of these we go to the end of the word, delete the line. There we go. Oh, all these bright ones are different. Bright black. Okay, so for these guys, we'll delete this space and then run the macro again. Nice, delete, 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 chillin'. And now we can cut this and go back to this and paste them in here. Boom. And all of these guys need a comma at the end. Boom. Chillin'. Okay, so now we have all these like control codes that we might support. We'll note non-exhaustive list. And so maybe what we'll do is we'll actually maybe put an unknown in here. And we'll write down the number that we got. Okay, and then we can say impulse select graphic condition, and we can like say function from usize. And so we'll say like val is a usize, and he's going to spit out a select graphic condition. Cool. And we'll just copy these numbers. And I guess these also should be foreground, right? Because there are also the same codes for background. But I don't really want to support the background ones right now. I'm too lazy. We're too lazy to do that. So we can match the value and basically just say 30 goes to... Ooh, we can get real tricky here. Yo, did you make a list of all the projects you built? I did not do that yet. But the YouTube playlists are like a pretty decent approximation of that. I think I've been making a playlist per project if the project goes for more than a couple days. So that might be a good start. Okay, so 30 goes to foreground black. Are these decimal or hexadecimal? I actually don't know. Looks like decimal. Okay. So what we can do is we can say copy, maybe go to like this, copy, paste, nope, paste this way, go back, and then there's like a control X to increment, no, control A to increment, there we go. Nice, and that's chilling. And then from 37, from 90, it's 90 here, and then we just do the same thing. Nice. Chillin'. And these guys all need to have their select graphic rendition in front of them. And we have to handle 0. Goes to select graphic rendition reset. And everything else goes to unknown with the value cached so that we can log it. Boom. Okay. Cool. So now when we get these guys, we just say, hey, each of you guys should be output.push terminal output SGR from this function that parses them, and we can just say param. And we can skip any that are none, because it's technically valid, I guess, to do like, I want, 0, 5, 10, and then put a bunch of semicolons and be like 11. I don't see any reason why that would be invalid here. So we'll just say if param is none, or let sum param equal to param else. Otherwise, we continue. if it is not something that we are capable, that we have got input for. Perfect. Perfect. Okay, so now we should have a list of like requests for setting colors. And now we just have to handle those in some way. So yeah, we're missing this part here. So how do we want to handle this now? Someone is parsing these terminal output things in our main terminal section. And here we just want to say like terminal output SGR. And for now, we'll just say print line unhandled SGR. And we'll maybe just write SGR here. Okay. So now when we run the terminal, and we run our test where we say, what was it? I already forgot. It was pager equals cat get log. Fuck. What's the problem here? CSA parser should not be pushed to once finished. So we made a mistake somewhere. We made a mistake, and I actually don't know what it is. Oh, it's probably here. Here, when we see that the CSA parser state is finished, we are supposed to reset our state, and we just forgot to do that here. All right. All right. So we can probably do that again. And probably this time now it'll work. Pager equals cat get log. Nice. So we're seeing a bunch of unhandled SGR, foreground yellow, unknown, foreground cyan, unknown, foreground green, foreground yellow, unknown. What is unknown 1? What is the 1 here? Bold or increased intensity. We'll ignore that for now. We'll handle bold later. Because I don't want to. I don't want to. Cool. So now we just have to figure out what the fuck do we want to do when we see someone asking us for a color code. Right now we're kind of handling everything as like we just put all of the text in a buffer. And so like there's like a couple things that we could do here, right? We could say that our terminal buffer is a like sequence of like colored segment of bytes, right? So this could be something like you would have like enum colored segment, and this would have like red. And this red would then hold the data that is supposed to be colored red. And then you could do the same for like green, right? Green, blue, whatever. It doesn't fucking matter. And then when somebody asks us for the data, we just give us the sequence of colored segments. But I think that will be a bit more of a pain because we also have like this thing where we support cursor movement, right? And so somebody can say like, hey, I would like to move the cursor left by 2. And now if we have like this sequence of colored segments, say we're in this green segment and we need to move the cursor left by 2, we have to kind of like accumulate the lengths of all of our segments before to like figure out where to go next, which is like kind of like maybe a pain in the ass. What make more sense is to like tag this buffer of data with its colors externally. So we could do something like color info. Okay. And this is going to be a vector of color. Maybe we'll call this terminal color. And it's not just terminal color. It's going to be terminal struct. We'll call this like a color tag. And the tag is going to be associated with his index, which is like where in the buffer he starts. Maybe we'll say start and end. You could do start and end and then color. We could do this. But do we really need the end? Right? Like, if we assume that everyone forward of a given tag is continuing to be that color, then I think it's fine. I think it's fine. So, yeah, that seems reasonable to me. That seems reasonable. Sure. And so now we just need to define the terminal color. Okay. And it's kind of weird. We could take this enum that we've already defined and use it externally. But you could maybe argue that the how do I say this? The GUI that is rendering the text doesn't really care about like SGR details. I guess it does. It probably cares about almost every single one of these. So let's do that. We'll just say that this isn't just a color. This is a SGR. But we don't really want to do that because you could have these like stacked together. I guess. You could have somebody, if once we support like bold later, somebody could ask for something that's like both bold and black. Oh, that's okay. Maybe it's not. Let's think about it. For now, I'm just going to duplicate these. For now. Because I don't want to deal with it. Deal with it. Style might be a better word if we were supporting style. But we're not right now. So I'm going to call it color for now and switch it to style later. And we probably also want like default here. Right? There's going to be some sort of like default rendering that we're doing. And then all of these guys are like modifiers to that default. Okay. And maybe we'll do like impl terminal color. And maybe we'll say like from SGR, which takes in the SGR of ANSI select graphic rendition and returns an option terminal color. Sure. And we will match SGR and do something like copy all of these and say, maybe not. We will do a macro, yank this word, paste it, make an arrow. This guy turns into select graphic rendition foreground. This first one's going to be wrong, but the rest of them should be right. And then this guy is going to go reset, is going to go to default, and then all of these guys are going to come and say terminal color here. Okay. And otherwise, it's none. Return none. And we're going to say here, let ret is equal to this, and then right at the bottom, some ret. Perfect. And they don't like that we didn't use this SGR thing, so we can put that in here. Okay. Color info is not of empty vector for now on initialization. Okay, and so now when we get this like SGR thing, we're going to say if let sum color is equal to SGR dot terminal color from SGR, we do something with that. We do something. else. We put unhandled. And he doesn't like that this was borrowed, so can I write clone here? And he doesn't have clone defined, so we just kind of go and shove a little clone here, because why the fuck not? And he's probably copyable, to be honest. I don't see any reason why I should have to write clone there. It's not like an expensive operation to duplicate an enum. And what are we gonna do with this color? Self, color, info, push. At like the current cursor position, I guess, the color. So we have our cursor pause. Get that. And we say cursor pause X is the X position of the color info. So we say what do we call this? Color tag? Yep. And his X value is this. The Y value is this, and the color is color. And oh, this is actually where in the buffer we are. So we say let buff pause equal to cursor to buffer position, cursor pause, and buff. There we go. So now we have where in the buffer we're supposedly at right now, and then we just say start is buff pause. Nice. And instead of pushing, we should say self color info push. Now this gets kind of odd, because say that we like move the cursor backwards and then change the color. We might end up with like duplicated colors, right? If we did like set or print ASDF, set color to red, print 1, 2, 3, 4. This should end up with ASDF and then 1, 2, 3, 4 in red. But then if we said move cursor to beginning of line, is it 2 ends? Beginning? Why? Why is it 2 ends? Okay, sure. Move the cursor to the beginning line and then print 1, 2. I think that we should see like red 1, 2, then DF, then red 1, 2, 3, 4. I think. Because this 1, 2 would like overwrite the stuff at the beginning, but not everything else. I wonder if we can test that somehow. There probably is a way to test that. Probably. There's a like cursor control. This guy's probably where we're gonna want this. Cursor. Move cursor up position, move cursor to the beginning of next line, beginning of previous line. Oh, you can just use a carriage return actually. Okay, so we did like echo. So this is our test thing. And if we said before any of this, we're gonna say ASDF test. We're gonna use 1, 2, 3, 4 like we did in our example. And then if we did like a carriage return type 1, 2, exactly what I expected, right? We need to keep the color state as we move the cursor around. So this is actually like pretty complex, actually, I think. I think probably we actually want to like make a struct color tracker. And inside him, he's going to have these like color info sections. But we're going to have like complex behavior on him. And we're going to say like function update cursor pause. How do we want to handle this? I don't really want him to keep a reference to the cursor position, and that's tracked like here. So I haven't really decided yet what I want to do there. Speaking of, my indexer's fixed. I don't know why the fuck it wasn't working before, but it does look like it's working now. Okay. Well, that's good. And so what is our API going to be? We're going to like push info. And this is going to be not terminal colors. This is going to be color tags. This doesn't have to be public. And I guess what happens here? We push. I don't know how I handle this. Because if I type a carriage return, he needs to know. He needs to like update every time. Okay, sorry, let me say this again. Say I run this test, right? Where we echo some stuff. It's white then red, and then I carriage return and type some more. In the scheme that I was initially thinking of tagging these like colors externally, at first I would say white, ASD, white at index 0, red at index 4. Great. But then after the carriage return, every time I get any input, I have to then say, oh, let me update red at index 0, then red at index 1, and then white is going to be the index after that. And I have to do that for every character. So I wonder if like having the color tracking be separate is creating like unnecessary complexity here. Because what does the color tracker need then? In order to support the carriage return, he needs the color info, and he probably also needs the buffer, and he probably also needs the cursor pause. Am I high? Does he need all those things? Does he need all those things? So I push in, I say, hey, somebody asked me for red, and now here's some data. He's going to be like, oh, okay, I have the data. I know my current cursor position, so I'm going to put the data at that cursor position. Actually, we don't even support that right now anyways. Right now we can set the cursor position. But I think that if you set cursor position without clearing, it won't behave as expected. So maybe we just ignore all of this for now. And we do it wrong. We just don't handle that. Because right now, if we set the cursor position, I think that when we get data, we don't consider where the cursor is right now. Which is a problem. We should fix me insert at cursor position. Do I want to fix that now? It makes sense to fix that now, because we're thinking about it. And it has implications on how we should lay out the color data. Yeah, okay, we can fix that now. Fuck it. Let's go on a little side quest. We'll go on a side quest and fix this. So we'll say at 01, 08, 10. Fix how do I say this? Overwriting after cursor moves. Okay. Okay. So what do we do here? I guess we look at the cursor position and we find the buffer positions. We say let buff pause equal to cursor to buffer position. So we take in the cursor position and the buffer to compute the new buffer position cursor. And if then we say self buff pause onwards. This is where we're writing to. Okay, and if output len is less than data len, i.e. we have more data to write than is left in the buffer, we say what? Remaining len is equal to data len minus output len. Okay. This is the amount of stuff that we have to put in that's like larger than what we already have. And this extend from slice now. We like extend the buffer with data remaining len onwards. Okay. Okay. Yep, that makes sense. And here we just say output copy from slice. I guess we need to find, I think that the slice sizes need to match. So here, what we find, this is output start, not buff pause, we'll call it output start. And let output end is equal to output start plus data len. Okay. And if output end is greater than output len, we do this. Okay. Where remaining len is the data length minus something about this wrong. Data len minus output end plus output start. I think. That sounds right. And what's the condition here? If data len is greater than buff.len minus output start. Now, something about this is wrong. So we have like output start. What is the condition here? If output start plus data len is greater than buff len. That's the problem. Yeah. Then we need to push some extra shit in. And how much do we put in? We put in the stuff that's past the buffer length. Output start buff len minus output start. Is that right? Buff length minus output start is how much of the data we could put in. So the amount that we have to remaining len. Yeah. Let remaining overflow start, we'll call it. Overflow start. It's equal to this. Aha. I think that's right. And then we copy all of the stuff that fit. So output is output start to output end. I guess we also need the like copy end. Yes. Okay, the copy end is the same thing. Copy end. Ah, okay, this is all making sense now. This is making sense now. I guess there's also the case where the data is shorter than the buffer. So we have like, we also need to clamp this if this distance is larger than data length. So if copy end is greater than data len, no. Oh, let copy length is equal to okay, let copied data end. Here we go. Is this guy. Is fuck. Nope, that's already here. This output end is the copied data end. Okay. Which means that we need to take this we'll call this like current. What the fuck is this? Buff.len minus output start. What, this is copy length? But only kind of like sometimes. I'm high. I'm fucking high. Okay. Output start, copy data end, let output overflow. We'll call it overflow start. I think that makes sense. Overflow start is equal to God damn it. Dude, my brain is just not working. I hate it when this happens, man. It's so simple. All we're trying to do is fucking take a thing of like A, B, C, D, split it into like A, B, and C, D. If at where this like split point is defined by the end, like how much fits in the current buffer. Oh, that's not fucking hard. That's not hard. Why am I fucking like losing my mind over this? Okay, so let's start with like amount that fits. Simple. Is equal to the current buffer length minus the output start. Simple. Simple. Okay, now we take the data and we split at amount that fits. Let copy data to copy is the first half, and data to push is the second half. Holy shit. Why was that so fucking hard? Okay. Now, does split at allow if mid is larger than length? Panics if mid is greater than length. Okay. So now we have to handle the case where if amount that fits is greater than data len, we just return data and an empty slice. Holy shit. Okay. Data to push. And if it's not, then we do this. Holy hell. God, I'm so mad. But it's fine. It's fine. Okay. Do I have to do this? This has to be a slice of U8. And this also has to be a slice of U8. He doesn't like that. Maybe it's the, like, this. There we go. Okay. So we extend with data to push. Holy shit. Okay. And we say self buff at output start plus data to copy len. Copy from slice. Data to copy. Holy hell, man. I think that's it. Now, there's a good chance that I fucked something up and just typing into the fucking terminal at this point just won't work correctly. So, let's just run it and see. Yep, range index 4, out of range for slice of length 0, 178. Right, because amount that fits is greater than data length, else split at amount that fits. We're missing a case here where the amount... Wait, let's print line amount that fits. I'm assuming this is 0 on the first push, and that's probably just not being handled correctly. Oh, he's saying it's fucking huge. 4094? Because this is fucking supposed to be self.buff. God fucking damn it. there's a local buffer and the global buffer. That's great. Okay, so now we're at 171. Failed to distract with overflow because the cursor position is past the end of the buffer. That makes sense. So if output start is greater than self buff len, we can just, so let's see. If output start is greater than this, then we do just the normal extend from slice. I guess we're asserting here that output start is equal to self buff len plus 1. Probably. Assert equal. Right, we want to make sure that we're only ever trying to push right in front. And this is continue. We're fucking dunsy. He doesn't like that. Because the cursor to buffer position stuff is somehow saying that before anything, my output, my cursor's at 0, 0. Oh, because we update the cursor first. So we just do update cursor at the end. Which I think also makes sense. Okay, that's working. That's not. So now when we get a new line, it seems to think that we're at the wrong location. It's not handling... It's... What the fuck is going on? D, 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 enter. D, 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 enter. D, 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 D. It's like not handling the prompt line correctly. Okay, so that might be a bug in our, like, cursor to buffer position stuff. So here, we split at new lines. Y is determined. So we take the cursor position Y, and we count all the new lines in our buffer. Okay. Then we add in the X position. I don't really see how that could be wrong. Can't understand how this would be wrong. Let's think about this. So it's clearly in this case that, well, no, let's, yeah, we're hitting two cases. Amount that fits is sometimes non-zero, which is kind of surprising, because I would think that in, like, the case where we haven't moved the cursor, we should always be hitting this case. So why is that not happening? Oh, because we didn't update the cursor here. God damn it. Oh, and then some output. No, I'm missing something. I'm missing something. Let's go back here and just remove all this stuff and only handle the case where we're appending data, which is basically what we were doing before any of this. Before any of this, all we were doing was ever appending data, and now it's just fucking broken. So this is maybe greater than or equal to is a mistake that I was making here. Off by 1. Remove this assertion for a second. Okay, so the first ls worked, but now all of a sudden on the first new line it's not working. Let's just print out output start is this. Buff len is this. What am I missing? So I ls something. Output start and buffer length are the same. I press enter. Now all of a sudden, output start and buffer length are different. Because probably I'm not counting the new lines here. Because we're splitting by new line, and then we're counting, but we have to +1 for each new line. Is that right? For each new line, we have to increase the count by 1. That makes sense. Okay, now this is working. Okay. And now we can go back to trying to handle this other stuff here. And I think we're probably chilling. Let's see. Let's see. So ls, clear, ls. And now we have to maybe try something that will like move the cursor backwards and then try typing again. So, does that not work? Echo \r, echo \r, echo -e \r, ASDF, ASDF. Okay. That should do it. So echo -e ADSF 1, 2, 3, 4. Oh, right. We don't handle carriage returns. Of fucking course we don't. That's the easiest way to test this. So we're just going to... We have to handle carriage returns. So I think that's pretty easy. I'm pretty sure that's easy. We can just say... If we... whose responsibility is this? Seems kind of like this guy's responsibility. So we'll just say like carriage return. And if byte is equal to \r, then we what? Output push terminal output carriage return. Okay. Oh, but then if we get like /r/n, if we just like move the cursor back, then push a new line, that's gonna like push everything in front of it. Ugh, that's so annoying. That's so annoying. Can we use another command? Can we use like a cursor control command to do this instead? Moves cursor left number of columns. Moves cursor up one line, scrolling muted. Moves cursor to column this. We could do this. Let's do that. So we'll handle a cursor G. And we will assume a single parameter that will try to move the cursor to the first thing. And so maybe our set cursor pause will allow for option usizes here. To say like, hey, please move the cursor, but if I pass in none, then I don't care, like just leave it where it was. So, makes sense to me. So everywhere we were resetting the cursor before, we put some, and now we're gonna say let X position is equal to this. Okay, and we push a set cursor position with the X position set to the X position, and Y position set to none. Okay. All right. So now somewhere we have this like set cursor position, and if let sum x is equal to x, and if let sum y is equal to y, we do this. Code build. So terminal emulators process every character out of sound output for the process running inside it. Yeah, I think so. As far as I understand it, that does seem like how it has to be done. Which seems kind of wild. I think like the whole scheme is like kind of fucking funny. Like this like terminal is built to be run over like a UART where like all of the data control goes over that UART. And so like you only have like inline data, so you just like shove some inline data in there to move the cursor around. It's like, surely we could do better at this point. And so like now all of our terminal emulators are like emulating a UART so that we can get all this behavior. And it's like, that doesn't really make any fucking sense. Like, I don't like, that's why you have to have these like pseudo terminals, is because like there's like expectations about how they're supposed to behave. It's very strange, very strange. Okay, cargo run. Clear is working. LS is working. Clear working. Okay. And now we can try doing one of those, like, instead of \R, we can do 033 escape 1G. Perfect. This is the magic command we need to get the test working, where we write ASDF, go back and overwrite it with 1, 2, 3, 4. And now we just have to type that very carefully because I don't support backspace right now. Echo -E ASDF 033 1G 1, 2, 3, 4. He didn't like that. He didn't like that at all. I wonder if this is because like, is this because we're in like fucking Ash that doesn't support it? Echo -E ASDF 033. Oh, I forgot the open thing. 1G 1, 2, 3, 4. Was that? Oh, I just forgot the open brace last time. Okay. Let's try that again. Echo -E ASDF 033 for the escape. Open brace 1G. Set the cursor back to the first column and then type 1, 2, 3, 4. That crashed because CSR parsers should not be pushed to once finished. Same fucking bug as last time where we just forgot to set the state when we handled the G. We have to do this like set the parser state to the new reset the parser, please. Echo -E ASDF 033 open brace 1G 1, 2, 3, 4. Hell yeah, baby! That's sick. Okay, so that looks like it's working. If we did something a little more clever, we could say echo -E ASDF 033, reset the column back to the third column. 1, 2, 3, 4. AS 1, 2, 3, 4. Hell yeah, baby! That's sick. So it looks like we're now correctly keeping track of the cursor and like overwriting data, correctly splitting it so that it's like appending when it needs to, overwriting when it needs to. That's fucking sick. Okay. So all of that was because we wanted to be in like a reasonable state for handling color. Specifically, we were trying to think about, so if somebody sets the color to red, then moves back to the beginning of the line, we need to like remember that we're writing red. So I wonder if maybe storing the state in the cursor makes sense. Because we're using the cursor to track Can you press Control plus in Termite? In Termi? I wish I could, but we can maybe take a... You're right, that is kind of fucking small. So we can fix that. I think it's in here on initialization. You can say like CC, eGUI, CTX, set pixels per point. And we can set that to like 2.0 or something and just see cargo run. Good call on that. It is really fucking small. Much better. Much better. Right, exit just fucking breaks as well. Everything breaks it right now because this is a terminal emulator is a piece of shit. Okay, so let's store let's store the current color. Maybe we'll store this private because we don't need that to leak externally. We'll maybe store the current color as a terminal color. Then when we are writing, we can check the current cursor color and use that to update our dictionary of like what sections of the thing are what color. I think that makes sense. Okay, and so on initialization, we're going to set his color to terminal color default. Okay, that makes sense to me so far. And so now, what does our like color tracker look like? He's gonna hold on to, I think, still making sense. Holding on to like areas that are colored makes sense. But I think the API now can just be like push range. And we'll pass in the current cursor color as a terminal color. And maybe like a range that we wrote to. Which is, I think, what? Range usize. Range usize? Which means that we need like ops range or something. So the idea here is that if we are at like, we are writing to some location in our buffer, and we know the current color that we're writing with, and so we can update our like database of things with that. We probably want to implement some sort of sort by the start position so that we can do like a binary search for the start of the range. Okay. So what? You're going to have like... well, we'll see. This also needs to take in self-by-mutable reference, of course. Okay. So what happens here? We say, I am writing to 3 to 5 with red. What happens in that case? We create a color info of that thing, color tag, where his start is the range start. Okay. And the color is just the cursor color. So we can just say what? Self color info push. Okay. And now the problem is, before we do that, we have to actually look for anything where the range is, where the start is within this range, and reset it to the end of the range. I think that makes sense. So we can like say for item in mute color info, maybe we'll call it info. If info.start is greater than range.start and info.start is less than range.end, we have to like do something about this. And so let's just say info.start is equal to range.end. And well, so here, if we have like 3 items between the range, say we're inserting in the range like 3 to 10. We're saying like we're making 3 to 10 red. Say before we had like 3 is green, 5 is yellow, 9 is orange. We kind of want to just like delete these guys in the middle. So we almost want to like find all of the elements that are within the range, delete all of them except the last one, and then update the last one. Maybe? That sounds reasonable to me. I don't fucking know. Let's try that. So we want to do something like, we want to like keep this guy sorted. Let's how do I want to handle this? Can we like impl ord stood comp partial ord or color tag for color tag? Okay. Implement missing members. And what is an ordering? Less, equal, or greater. So we'll just say self.start comp partial comp other.start. This is the way that we are sorting these guys. We don't care about the color. We only care about their insides. And so maybe we don't do it this way. We just we don't say that the color tag has that sorting. We'll just sort based off of the color tag start. Okay, so maybe we find... Nah, we don't have to do any sorting at all. Let's do this. We're gonna look for the color infos. Self color info, where we're gonna turn this into an iterator, and we're gonna filter these for items where the item.start is greater than range.start, greater than or equal to, and item start is less than range.end. Okay. Then we're gonna like collect these into a vector, but we're also gonna keep track of their indexes in the original. Yes, yes, yes. So this is gonna be in a vector. I think we're getting somewhere. We're getting somewhere for sure. Well, maybe not for sure. We're maybe getting somewhere. We're gonna sort these by do I take A, B, I think probably in here, and then we say A.start comp B.start. And this should be A.1.start and B.1.start because these have their indexes. And we remove the semicolon and consider borrowing. Okay. What did I fuck up? Remove the semicolon, yep. Okay, so now these are sorted by all but the last one. So now we can delete. We can say to delete is equal to infos. All of them but the last one. 0, 2, 0, 2, infos.len -1. So maybe we want to do if infos.len is greater than 1. We delete a bunch of them. So we say to delete is equal to infos iter map ix our I item. So we have like the indexes that we're deleting from the initial thing. Okay. This gets collected into a vector. Okay. And then we need to sort this again. Because we need to delete in reverse orders for the indexes not to like fuck each other up. So then here you would say for idx in to delete dot iter dot reverse self color info remove idx. Okay. Consider dereferencing the borrowed. Oh, into iter. And now all we have to do is handle fixing the last one. So maybe we want like iter and mute here. And we just update the last one. So we just say infos dot last if let sum info is equal to info's last. Info dot one dot start is equal to range start, range end. So now we've healed the last one, deleted all the other ones, and now we insert the one with the new thing. And I think we're chilling. Holy shit. Let's go, baby. Last mute here, probably. Wow. I'll be surprised if that works. To be honest. To be honest, I will be surprised. Okay. So now we have a color tracker. Color tracker. And I guess he's going to have new. Trackurer. Did I put a U in there? I probably did somewhere. We'll fix it later. This guy returns a color tracker. And oh no, you're just being a goob? Wow, you know, I typo so often, I just assume you guys are fixing my mistakes. I'm also shocked at the frequency where someone in chat is like noticing a typo. Because when I watch this type of content, there's no fucking way I'm ever noticing that. You guys, some of y'all are like paying attention. So I guess his initial state is going to be a vector where he has like a color tag with the start at 0 and the color as terminal color default. Right? That seems reasonable. Sure. All right. This seems like one of those things that's like, obviously we should unit test this because I'm not really very confident in the implementation at all. And it's easy to fuck up. And I think it's easy to test as well. So we can say function basic color tracker test. And like, what's like the simple test here? We say let color tracker is equal to color tracker new. And we insert something. So we can just do like terminal color red. Well, what if we did like the same thing we did before, where we said we put like we start with orange, like red at maybe default at 3 to 10. Then at 5 to 8, we put in blue. At 8 to 9, we put in green. Okay. And then we want to say, let's put red at 5, let's say like 7 to 11 or something. What we should get now is we should get default at 3 to 5. Blue, let's fix some of these numbers. This should be 7 to 9. Okay. And 7 to 11. Okay. So you should see default at 3 to 5. Blue at 5 to 7. Green at 7 to 9. And red at 7 to 11. Which means that this green is gone. And maybe let's make this 6. So that this blue goes 5 to 6. And we should see red 6 to 11. So which means that our color checker needs a way to like figure out what the sequence is. So maybe we like return some sort of like iterator of color ranges. Right? Like we get like a range and a terminal color. I don't know. Sure. And so what we're gonna like, I guess here, every time we push something, we can say self color info sort by A, B, and A1. We can just do the same like fucking sort here. And like this. Right, so we just want to like, why is this? Oh, this has to be like this. So, right, so just to make sure that everything's in sorted order initially, or when we start this iteration. And then when we run the iteration, we can go, and maybe this should be fix me insertion sort, right? We should know where we're going to put this guy, but I'm too lazy to figure that right now. Okay, so we're going to say self color info. And we're going to iterate over it. And we're going to map items to this new thing. You kind of want like windows. Because you kind of want to know where the next thing is. Maybe we'll simplify this by just returning a vector of these things for now. So I don't have to think about like iterator shit. And we can say for I in self.color info len 0 to that. Let self.color info color info I is going to have something associated with them. Let end is going to be the next thing. So self.colorinfo.get I plus 1 map x.start unwrap or we need to know the size of the entire buffer, which we actually don't know at this point. So maybe for now, we just do like usize max. This is kind of fucked up. Track actual buffer length, maybe. But maybe that's fine. So our range is going to be let item is self.color info I. And so our range is going to be item to end. Item.start to end. And the color is going to be item.color. And so we can say let mute output is equal to vec new. We return the output at the end. And we say output push this. So we can call this items colors. Sure. So now we should be able to say color tracker colors. And we should just be able to say assert EQ colors is equal to what we expect. So we expect 3, 5 terminal color default. Using default here is kind of fucked up. Let's use like orange. No, orange doesn't exist. What are my options? Yellow. We'll use yellow. Because we expect 1 to 0 to 3 to be default, because it was our default state. Right? We expect 3 to 5 to be yellow, 5 to 6 to be blue, and 6 to 11 to be red. All right. Target test. Doesn't implement debug, so we can fix that. We can just say derive debug. Test that bad boy. He doesn't support EQ or partial EQ. Fix that as well. Fuck, we didn't fix all of these tests before when we switched this guy from being options to not options, so we just have to fix that real quick. God damn it. Is there some end of word 1? Okay. Nope. Some end of word. Some. This is super fun. There we go. Got the macro for it now at least. But it didn't work there. Okay. Target test, please. 287, we missed some. Oh, oops. All right. And now at mod, this is 192. We're missing the color tracker. Okay. Move per occurs because it doesn't have copy, so do I just need to borrow there at 171? This. And can I clone this? I can. I think we're chilling almost. Okay, so it doesn't work because we got 11 to max green. Ah, but that's actually shockingly close. So let's check here. We should be seeing, fuck this red shit. Blue should be 5 to 7, and green should be 7 to 9. Oh, that's interesting. So when we push something in, we never set an end state. Because we were kind of saying, well, everything is going to be continuing on from its start. And so for green, we just say it goes for the end of the world, to the end of the world, which makes sense. So then I understand that, but I don't understand why green made it out before. So I think there's like a we're missing an extra deletion case. Where here we said, okay, so we have yellow, blue, and green. Sure. But when we inserted the red, we kept green because it was the last thing in the range, and we updated it. And because we don't keep the ends, we can't know if green is like an empty range now, which is kind of fucked up. So maybe we do just store the ends. That makes things easier. let's do that. And here we'll just say uSize max as our default end. Okay. And so now the end for this guy is range end. Okay. And now we just have to handle these like deletion cases again. So now it's no longer so simple as checking the start isn't within the range. We have to check that the start or the end is within the range. So we almost want like function like ranges overlap. And we can take in range 1 and range 2. And maybe we want to do something like, I wonder if ranges have like a comparison implemented in Rust already. They might. So stood ops range. Does he have like a comparison? So we have what? We have like 4 cases here. A is completely less than B. A is completely greater than B. A is starts before B and ends within B. A and starts within B and ends after B. And then I guess we have like A completely encloses B. Those are our cases here. So I guess we can say if A.start is less, or A end is less than B start, we return false. So that covers this case. If A.start is greater than B.end, greater than or equal to, also return false. That is this guy. Okay. So otherwise, A end, we know that A end is greater than B start, and we know that A start is less than B end. So I think that probably just covers the rest of the cases. Because in this case, the ranges have to overlap in some way. Okay. Sure. So now we're filtering by anything where the ranges overlap. And range.clone. I think we have to clone it here. Okay. So now we have all of the ones that are overlapping. And okay. So if we now delete in the case where what? The range is completely encapsulated? So we delete if new range completely covers old range, delete. Otherwise, we have to delete. Otherwise, we have to adjust the end of the start to get out of the range. That makes sense to me. Okay. Okay. I think I'm getting somewhere here. We're getting somewhere. Let mute to delete is an empty vector here. We're not gonna do it this way. And we're gonna iterate over each info. And we'll call this like colliding infos. Hey man, how's it going? It's going good. It's going good. We're working on colors in the terminal emulator, and we're struggling, but we're getting somewhere. We're getting somewhere. So these infos are the ones that are affected. So we'll call this effected, affected. Which one's the noun? Effect, I think. Effect or affect. How to affect uses a verb to act. So it's going to be affected. This is something that yeah. Affected infos. So these are the ones that are going to be affected by pushing the new color. So for each one of these guys, if the info start is greater than range start, and info.end is less than or equal to range end, I guess we're going to say greater than or equal to, this means that we're going to delete it. This is like no longer relevant. So we're going to say this is info.1. I guess for each of these. To delete.push info.0. Okay. Else if info.1.start is less than range.start, and info.1.end is greater than range.end, in this case, we are getting like split by the new range, which means that we kind of need to heal this guy. So we'll say that our end range, the end of our range, is now equal to the range start, like the input range start, right? And we need to now push a new thing. So we'll make a new thing to push, because we can't just push it right now because we're working with the vector. We've got references already. And we're going to say to push, and we're going to create a new color tag. Yes, and the start of this thing is going to be the range, the end of the inserted range. The end of this thing is going to be the existing end of the range. So info 1 end. Yep. And the color is going to be the existing color. Okay. Else if info.1.start is less than range.start. Here we know that we're only healing the end. So we just do this. Else if info.1.end is less than range end, we heal the start. Hell yeah, baby. Okay, so now this is gone. We have this to delete. We remove all the things that we wanted to delete, and for item in to push, we push it. That's fucked up, but maybe that's right. Let's see what we get now. Can I propose a reward for channel points? Yeah, you can propose whatever. I can't promise that I'll look at it, but, 5-minute light mode in terminal of him. I mean, I should just fix that overall. But this is close. This is close to what we wanted. So we got 0 to 3 default, 3 to 5 yellow, 5 to 7 blue, 7 to 7 yellow. Hold on. Let's look at this again. So let's add assertions at each point here. So here, I want default 0 to 3, yellow 3 to 10, and then I expect 10 to the end of the world of default. Cargo test. We need to pull out the colors. Okay, so I think that first test passed. Let's comment out the rest. Comment out the rest. Okay, so this is working so far. Now let's push in blue and see if we still get what we expect. So once we push in blue at 5 to 7, this yellow section has been split into 7 to 10 yellow, 3 to 5 yellow, and now we have blue at 5 to 7. And does that still work? Hell yeah, baby! Okay, then we push in green. And we should expect actually the same thing that we had here, except now green is in here as well. So green is at 7 to 9. So here we have 7 to 9 green. 9 to 10 is still yellow. And everything else is default. Okay, so this isn't working. So why? Because 7 to 7 yellow. This is fucked up. So when we healed the yellow after inserting the green, something went wrong. So what is this? What is this case here? This case is where the starts match, but the ends do not. Okay. So what did we end up with? We ended up with 7 to 7 yellow. And we, so we have 7 to 7 yellow, and we didn't insert the 9 to 10 yellow after. 7 to 10 green. Let me double check this is what we expect. We insert at 7 to 9 green. And before we had 7 to 10 yellow. So surely we should end up with 7 to 9 green and 9 to 10 yellow. That makes sense to me. So it's got to be something with this here, where we're saying here we... So this part was right. So we say the start is less than the range start and the end is greater than the range end. We're splitting it. This should be less than or equal to, actually. I think that's now correct. Maybe we should panic here and saying unhandled case. And then print out start to end, start to end. That will give us some clues. Info.1.start, info.1.end, range start, range end. Okay. Okay. So we're not hitting the unhandled case. And here we need to check if info1 start is equal to info1 end. We delete it. And if range.end is not equal to info1 end, we insert a new thing. That way we should get rid of that like 7 to 7, which we didn't, surprisingly. So what's happening here? Why is this 7 to 7 existing? Okay, if range start and range end is less than equal to range, we delete it. Yep. Can we just print out? I just want to print this just to get a feel for where we are. So this should be print line, and this should be unhandled case. This should say overlap case. So we should be seeing we're 3, 10, 5, 7. Oh, we're not hitting that case with the 7 to 9 on green. Oh, maybe we're just not. This is the case where start. Okay, our start, the current thing that's in there, yellow, is less than or equal to range start. That's true. And the end, 10, is greater than the range end. So what the fuck is the problem? Let's just print line. Let's print everything here, actually. We'll print for each info. And that will give us a clue. So when we insert green, we have yellow at 5 to 7, and we're inserting green at 7 to 9. Oh, okay, so that makes sense. Yup. So how do we end up with 7 to 10 green here? Oh, do we? Yeah, we do. So this is fucked up as well. How the fuck is green getting range end at 10? Hello? This makes no sense. Okay, so first of all, we have to handle the case in both of these guys. We need to delete anything where it's 0 length. So we can just do that here and here. So that'll at least slim us down a little bit. That should delete the 7 to 7 yellow, which it doesn't. Hello? How is that 7 to 7 yellow staying in here? Because here we're seeing start is equal to end, and we're deleting it. What the fuck am I missing? What the fuck am I missing? If range end is not equal and so we're getting case 5, 7 and 7, 9. Overlap case 3, 10. Oh, hold on. Let's maybe print line starting push. Sorry, that was in a loop, which is confusing to me. Okay, so here we find a thing at 5, 7 to 7, 9. Okay. We only... Let's log the color as well. So I want to see which color are we pushing for each of these. So pushing yellow, pushing blue, pushing green. Okay. And then we see our 5 to 7, which is our blue. And then we just don't see any other cases? Like, oh, because the other ones aren't affected. Oh, because the ranges overlap thing is bugged. Okay. That's making sense now. Okay. So we filter only for things that are overlapping. And maybe this is just not working correctly. So cursor color with this given range. Can we debug format the range maybe? Hey, just started watching your videos on YouTube. Gotta say, you and TS Oding are on a whole other level when it comes to coding streams. Litter content, keep going. Hey, appreciate it. So we're pushing green from 7 to 9. And we have a thing that's 7 to... Fuck. Ranges overlap is probably an off by 1 on a greater than or equals to. Almost certainly. Yeah, that's probably it. No? Am I high? I feel like I'm... Range overlap. If the end is less than the start. we do not overlap. Otherwise, if the start is greater than or equal to the end, we also do not overlap. Every other case, we overlap. I can't see why that's wrong. So when we push yellow 3 to 10, we overlap with our defaulting. When we push 5 to 7, we overlap with the 3 to 10 we just pushed. Yep. And then when we push 7 to 9, it thinks that we don't overlap with jack shit. But we have this case where, okay, 7 to 9. 7, can we print line A and B, the range is, B with the question mark, and overlap. Okay. And we're going to do this actually in this map here. Because I'm losing my mind. Okay, so overlap, overlap, overlap. Expected, oh, because this has to be in the quotes. And we'll put these in variable names. AB. So that we can log them. Jesus. Please. Okay. Oh! That's a good clue. So this 7 to 5 should be 7 to 10. He's fucked up. I see. So when we split up yellow, we've got these guys wrong somehow? I see. So starting push blue, 5 to 7. So we have 0 to 3 and 5 to 7 do not overlap. 3 to 10 and 5 to 7 do overlap. Okay. But then we still have something like 10 to 3? That doesn't look right. So who is fucking that up? What is the sequence of events here that could give us a 10 to 3? So we insert 3 to 10 that bisects the guy. Okay. Ooh-wee. Maybe at the end of this, each time we just print line color info. And he doesn't like that this guy doesn't have debug. Modprog rated with a party of 10 viewers. Hey, thanks for the raid, man. Appreciate it. Appreciate it. For those coming in, we are working on tracking colors in our terminal emulator, which is turning out to be somewhat complex. But we'll get there. We'll get there. We are working on a test where we are trying to track our colors by basically saying here's a buffer of stuff, and here externally is like the ranges in that buffer that has a given color. So like if I had everything white, I would have like 0 to the end of the world, white. And if I put a green section in the middle, I would say like 0 to 3 white, 3 to 10 green, 10 to the end of the world white again. And we're just struggling because state is hard. Okay, so when we push this guy in, we push in blue 5 to 7, who bisects this 3 to 10 yellow that we had in there before. And at the end of that, we have 0 to 3 default, okay, 3 to 5 yellow, great, 5 to 7 blue, great. And then at the end of this, we have 7 to 5 yellow. Okay, so that's the problem. Is this should be saying 7 to So sorry. So we put in blue 5 to 7. Yep. So we should have 7 to 10 yellow. But instead we're getting like 7 to 5. And then the end of the world one is getting somehow set to 3. So that got fucked up here when we bisected the original. So it's the end when we bisect is not wrong, right? Because we already healed it. Aha! Aha! So that's the problem here, is that we heal it and then we expect it to be the same. I see. So we should, if range start is equal to range start, we delete it. And then we can still use the old thing, and then we assign here. Okay. Let's see. Tests are passing. Great sign. And so let's do this last insertion where we push in a red at 6 to 11. And if this is our current state, we expect blue to be truncated to 5 to 6. Green should completely disappear. Yellow should completely disappear. And this will turn into red. Yes. And red. Then we have 11 to the end of the world. Still at default. Please, 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 please. Fuck, man. Okay. We were close. So here we were panicking at 195, saying unhandled case. Unhandled case. Oh, interesting. So we're missing the case where our thing is on the right side but overlapping. So this is info. We want to heal the starts. That's this case. So here we were saying if the info end is less than the range end, but that's not true. We just want to say if the info start is greater than range start. And I think that should be okay, I think. Yeah, that looks like it's yeah, it looks like it's working. For our like not very well thought through test. We've tested one sequence and that's working okay. And that's enough for us to say for now. Fuck it. It's working. Okay. So now. When we get a color request from the terminal, we're going to have to look at... Oh, here, we already had this code. So we get a request. We get the buffer position. And at this point, we just say... At this point, actually, all we do is we set the color based off of... We log the color in the cursor. Let cursor self cursor pause, which isn't really true anymore, what we're calling cursor pause. His color is going to be terminal color from SGR. And this is going to be if the color is something. So if the color is parsed properly, then we set the color to the color. Boom. Okay. Oh, oops. We already are in that part. Okay. So then all we have to do is when we push data, every time we put stuff into the buffer, we say self color tracker color info push. Okay. And we just push in a thing of that color. Yeah. So what are our parameters here? We have... this is wrong. Color tracker push. There we go. Push range. And he takes in the color of the cursor. And something else. But I don't remember what. The range. the range that we're pushing to. So self output start self buff len in this case. And here we push in this stuff. Okay. And here we push the range of, actually it's output start plus data len. There we go. I think that's right. And then here we have to like clone the color or something. And then we should also merge adjacent colors, but we're not gonna fucking do that. And I guess we're pretty late into our recording, but I do want to see if we can finish it. So let's see. Pub function, data with a colored data, we'll call it. Okay. And he's going to return an iterator or item or vector, we'll say. Well, I don't know. We'll see. I don't know yet. We don't know what he's going to return yet. And he's going to say self color tracker colors. Okay. And he's going to look over each segment and return the slice of that segment as well as the color that's associated with it. Sure. Hell yeah. Seems reasonable to me. Seems reasonable to me. So for info in colors, what is this guy? He is got a range and a terminal color. So we'll say self buff info dot range or info 0 and the color. So I guess what we're going to return is we're going to turn like some slices with their colors. Right? That seems reasonable. Sure. And so this is going to be like a bunch of them. Sure. Now, in the future, I might want this to be like an iterator-based thing instead of a vec. Because the vector is going to force a heap allocation. We're going to have to store stuff there. But you could like maybe do this, like lazily compute it with an iterator, maybe. Right? So I'm not really worried about that right now. So say ret is equal to vec new. And we just say vec or ret dot push this guy and this guy. Info 0, info 1. This probably needs an ampersand on him. To turn him into a slice, we need to probably put a semicolon here. And we probably need to return ret. And if we go into our GUI, when we construct our label now, we just have to make a layout job. Layout job. Which, if I remember correctly, allows me to push sections of different colors. Perfect. Layout section. Format, byte range, range of the galley text, format. Ooh. Okay. Where is like colors come in here? I thought it was layout section has text format color. Yes. It's all coming together. Okay, so we actually don't even take to fucking pull out the data here. We can just give out the ranges. Which means that we can just return this as is. Right? Right? Yes. Yes. Which means that here we can which sections of the galley? So can I not like this different section which have different fonts, the complete text of this job referenced by the layout section. So I think I can start by making a simple layout job and then pushing layout sections myself. Yes, that sounds right. Okay. Yeah. So let job is equal to layout job eGUI. Layout job simple. eGUI text layout job. Simple. It's a simple job, you know? And the thing is going to be this. To string on wrap, I guess, or to string, yep, okay. His font ID is going to be monospace. So where do I get that again? CTX style text styles. Text style monospace? What is this thing? Let styles equal to this. I think this is a font ID. This gives me, oh no, I want, fuck. Who takes in font IDs again? Fuck. Text styles. Yeah, it is text styles. Am I high? Oh, this is, of course. I don't put the brackets here. If I don't put the brackets, it's completely different. Of course. So I have the font ID now. And what else does this guy take in his simple thing? Color. So I guess we look for ctx.style.visuals.for font text color. Yeah. And the wrap width is going to be, I guess we need to find the wrap width. UI dot available width. Okay. And now we're just going to say let default layout section or I guess like the default text format is going to be job dot sections 0. Perfect. Perfect. We'll call it text format. Okay, 6. So now we can say for section in self terminal emulator colored data. And this is the range color. We are going to push in that range. Well, let's make sure that these are sorted because they might have to be. So say let colors equal this. Color ranges. Oh, we know they are. We sort them automatically. Okay. So we clone the text format. Job dot sections push. Yep. So first, we want to clear the sections. Job sections clear. Reasonable. And now we just say sections push a layout section that just, you know, looks normal. So leading space, nothing. I'm not sure if this is right, but we'll see. The byte range is range. Yep. And the format is text format. So we say text format dot. We need to set the color on this guy. So this guy has a color, and he's going to be defined based off of the color that we have from the terminal. Okay. So we have to go to terminal color, and we have to convert each of these guys into like eGUI colors, which is fine. We'll figure it out. Terminal color, and then we have to import that. And I guess before we do anything, let's just actually make the color the default color no matter what, just to see if the layout is still okay. So CTX, we can say here, let color is equal to this. Yep. And let's just put the color in here. Like that. Oh, no, we just text format. Format is equal to text format clone. Okay. I don't even have to do anything. I don't have to do anything. It's already there. And then here we just push on the job. This guy needs a monospace here. Now let's just see that without doing jack shit, is it okay? Arguments this function incorrect. Clone. Remove this mute. Okay, that's fine. Cargo, run. Is it okay at all? You know? Fingers crossed, baby. Fuck! Byte index is out of bounds. Ah, okay. So we just have to clamp. If range.end is equal to usize max, range.end is equal to self terminal emulator data len. There we go. Just because you have to fix that. LS? Okay. Clear didn't work, but this does. Okay. So we're on the right track. Now let's say that we fucking take the colors here, and this goes to a color 32. I guess this goes to the default color. Default color is equal to text format color. Clone. Okay. So this goes to default color. This goes to color 32 black. Color 32 red. Color 32 green. Oh, baby. Color 32 yellow. Hell yeah. Color 32 blue. Color 32 magenta. Nope. Purple. Nope. Do I have options? Nothing that really matches that. So we'll just use blue again. Because, you know, we're getting a little lazy. Color 32. We'll use blue again. Fuck it. And this will go white. And this can be match color. And they don't want me to clone this, I guess. Let's see if this actually does something. Pager equals cat get log. Woo! That's not right, but it's not awful. Right? We're seeing some form of like these colors here, head, arrow, master, origin master, and the yellow here, that's right. The only problem is we're not resetting correctly. But that is pretty fucking sick. That's really sick. That's really sick. Holy shit, that feels good. Okay. I think that we've got a pretty nice win there. And I'm way over time on like what a normal stream is. I usually try to limit these things to 2 hours, and we're at 2:45. And so I'm gonna call it here. We're close. I'm not really sure how much. I think there's probably more of this to do on stream. I don't know. I can't imagine that I want to finish this offline. I usually try to keep the real feature development on stream because I think it's interesting. So we'll probably be back at this tomorrow. There's probably more to do. At the very least, we have to handle like bold, italics, and stuff like that. So there's more to do for sure. I had like a bunch of stuff that we wanted to handle. So yeah, that was sick. What did we do? We started by parsing ANSI color codes that came out. We got kind of lost for a bit about why colors weren't working correctly in our like BusyBox environment, but it turns out that was like a little red herring. We parsed out ANSI color codes. We added this like color tracker that like marks what colors things should be as the cursor is updated. We fixed overwriting cursor colors. Actually, we should do that test again. We should do that. We had that simple test that was we echo -e. We echoed like ASDF, and then we moved the cursor back to the beginning of the line and the echo like 1, 2, 3, 4. And so here we get like A 1, 2, 3, 4, right? If we type that. But now we should be able to say ASDF, go back to the beginning of the line, but also be red. What color was red again? Red was 30. So we need 30 M 1, 2, 3, 4. Oops, 30 is black. But you can see that we got it right. Right? We moved the cursor back to the beginning of the line, we overwrite some stuff, and we write 1, 2, 3, 4 in black. So that's like indicating that we fixed also the fact that we wanted to be able to move the cursor around and overwrite stuff before that wasn't working correctly. And then added color support, hooked it up to the UI. Pretty productive, pretty productive. I think we got stuck a couple times at things that should have been pretty fucking simple. Does up arrow work in the shell? We don't propagate up arrow presses, so no, it doesn't. And somebody else has Envim looking, it looks like shit. It's like, oh, it's just crashing now. It used to look like shit. Now it's triggering some sort of like ungodly behavior that we haven't handled yet. But yeah, I think it's pretty good. Pretty good. Pretty happy with that. Pager equals cat git log. All right. So thanks for watching, guys. If you like what you saw, I stream most days at around 1 or 2 o'clock Pacific time for around 1 or 2 hours. Today's an exception where we hit 3 hours because I was struggling, as you do sometimes. But yeah, we stream most days. We try to cover a variety of topics. We've been doing like operating systems, AI, 3D graphics, terminal. What else? We did like a keyboard overlay at one point. I'm already forgetting. There's enough projects that I can't remember them anymore. But if you want to look at one of them, there's a YouTube link in the Twitch description, and there's like playlists attached to the YouTube that should have all the different projects we've worked on. And there's also a GitHub where the code should be, and a Discord if you want to get updates about when VODs are going up, when streams are going live ahead of time, stuff like that, and like to chat, shoot the shit offline. If you're watching on YouTube and you want to swing by and say on Twitch, there should be a Twitch link in the YouTube description. Thanks for watching, guys. I'll catch you on the next one. Bye!